Hello everyone. We are going to go through an experimental explanation of calculation of a precipitation. Now the calculation stipulates like this. It's a section on hydrology, precipitation, runoff and stormwater. However, we are going to be looking at hydrology in the precipitation content. Now the question is looking at figure 1.1. It is an area schemated next to Bizana around the Eastern Cape. Some of you may be familiar with the place if you are from the rural areas of the Transkei. We've got 5 rain gauges located in the area and they are in the sketch below. Now when they speak of 5 rain gauges located in the area, they speak of rain gauge 1, 2, 3, 4 and rain gauge 5. Now each of the rain gauges reflects the minimum precipitation measured from each in millimeters. And if you can see, the demarcation of the catchment is all around within the plan, and then they've managed to also give us a scale, which you can see in the grid line of longitudes and latitudes. And the scale is sitting at 0 to 200 if it's 2 blocks covered, and then 0 to 100 if it's 1 block covered. Now, how do the question look like? Now, in this calculation, you'll notice that we did talk on the theoretical part in one of the team sessions, that we need to understand the theory before we can engage on the calculation. However, now they are looking at you briefly explaining to them the Theisen Polygon Method used in estimating the average precipitation. Now, if you look at the marks, it's 4 marks. They're actually looking at you to be able to explain to one person how does a Theisen polygon gets executed. A Theisen polygon is something of this nature. How do you come to this point? Right. Now, if you look in terms of explanation on how really we can come to that point is in the following concept. Now, one would say, in fact, let us select one of the pens so that we can be able to write clearly on what we want to account for here. Now, say you've got a catchment that is sitting around a certain area. Now within the catchment, same as the example there, you may have rain gauges spotted across. Let's say you've got 4 rain gauges. Now, how do you then reflect the understanding of a Theisen polygon method? They say for a Theisen polygon method, the rain gauges that are reflected on the plane, on the ground, must be in the similar positions on the map, which is what we found here. Now, those rain gauges need to be joined with straight lines. Now, after joining the rain gauge with straight lines, you perpendicular bisect each of the rain gauge. Now, after perpendicular bisecting the rain gauge, that means you can then extend the perpendicular bisects into forming polygons. Now, why would we do this exercise? Is because we want to actually conduct the impact areas. Now, the impact areas will be the areas that are covered by this polygon. That is the area by which the rain gauge is effective. And also the areas covered by this polygon on the other side, the areas by which the rain gauge is effective. You must take note of that. Your lines can extend to as far as there, but remember the boundary of the catchment only ends up to here. So your polygon, your impact area only ends up to where the boundary is sitting. Right. So as well carrying on to say we need to then adjust now to see how then can we calculate the same thing. We need to then adjust the calculation now. Now if you come to the calculation part, they ask you about the precipitation, and they ask you about the precipitation, and they expect you to determine the effective total area of the catchment first. Now, when they want you to determine the effective total area of the catchment, it's because they want to see if ever are we going to measure the precipitation versus the area of impact. As well as they say by the use of both arithmetic mean and Theisen polygon method, determine the aerial rainfall in the catchment of this same figure. So now we are going to go through a situation by which it can assist us to determine what is required. Alright, now let's go down to the next page so that we can start the calculation. Now, in determining the same rain gauge, the precipitation, you look into drafting up a table. You look at drafting up a table. Maybe the pen doesn't want us, it wants the class to end today. You draft up a table, and on your table you need to reflect the rain gauges. And from the rain gauge, you need to reflect the millimeters of each measurement of the rain gauge. Now, if you look into that, you'll be saying we've got about 5 rain gauges. Now, from the 5 rain gauges, you then stipulate, you give a reflection of the expected millimeters, looking at the drawing itself, at the figure that you have provided. All those are millimeters of the rain gauges. Now, there are 2 methods that you are told to use. There's an arithmetic mean and there's a Theisen Polygon Method. Now, for arithmetic mean, it simply says you take the values up, you add them together, and then you divide it by the number of rain gauges. Simply remember that the calculations that you are conducting here are 2 calculations, the Arithmetic Mean Method as well as the Theisen Polygon Method. Now, the Arithmetic Mean Method is a simple calculation that works with the precipitation over an area divided by the number of those precipitations. It's a simple average mean method. Now, if you look into that, you then consider these values here of the precipitations and the number of rain gauges, and then you get a value sitting at about 562 millimeters of precipitation. And then, the similar situation you can look at when you are doing the arithmetic and the Theisen Polygon Method. Now, when you're doing the Theisen Polygon Method, you take into cognizance of the areas within the area of the impact area, as well as the scale area, as well as your precipitation times the area. Now, these are the important figures by which here you are looking at the sum of the area, as well as the sum of the P times A. Now, this one gives you a formula that sits in the context of P1, 2, divided by the sum of the area. Now, what is important for me now is to explain to you how do you then determine the area if you are provided a, say, you are provided a, what's the name is, you are provided a structure. You are provided a structure in the context of a map. So how do you then determine the area from that map itself? Now, for one, we need to understand that within a map, understanding that there was a scale, but now the scale already exists here in the context of 100, as well as we said a block is about 100 meters. And then we said when the blocks are 2, they talk to 200 meters. So now, within this area, what we do is to calculate the blocks. Now, rain gauge 1, we calculate how many blocks do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 full blocks, but now we need to then assume in terms of other blocks and correlating and get the actual amount. We said 15, right? So 15 is, then we come to this one, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now, you do that in all the calculations. You do that for this block, then you understand that you've got about 24 blocks. Then from the 24 blocks you have, you multiply by the scale of each block, and then you get your area. and then you go to the next. Even on the next, you start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And then you can say 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. You get about 32. Remember, you can't always be exact because at the corners and at the half of the blocks, you are assuming that it's 20%, 30%, 50% full. And then you get your areas. You then multiply the same areas by the scale, and then you get your total. Now for this one, you will need again to make sure that you are on the same page with us. You will then come back to the formula itself. When you get to the formula, you would be expected to have written the area, scaled area within the blocks. And then you also multiply your precipitation here. You multiply your precipitation here in millimeters, multiply by your scaled area here, and then you get your values. Now after you've determined the sum of that, that is where it's going. On top there, that's where the sum of it is going. And then the sum of the areas themselves, that is where they are going, you see. So that is simply what you can do to determine the arithmetic mean method and then get the values of 576 millimeters. Whereas in the other one, we got about 562 millimeters. Now, if you look in terms of the two, one question that comes next, which of the two rainfall precipitation seems to be correct? Now, the one that seems to be highly correct is the one that consists of the calculation that involves the impacted areas, because the other one is a simple average. So the one that is almost correct, that most engineers are using in the industry, is the Theisen Polygon Method. So for now, that is where our class will end, and then for the future, we'll be looking at the runoff calculation, by which we'll be able to determine over a catchment area. So yeah, that's where we end for now. Thank you. See you next time.